We can use ASAP as part of a simulation of a finite difference time domain problem by using the interoperability of ASAP with the FDTD Solutions program. In this particular case, what you would use is ASAP to model the simulation of macroscopic components. You would then use the FDTD Solutions program to perform analysis in those regions where microscopic detail needed to be considered. Let's take a look at an example. In this particular case, a digital camera. With the digital camera, we have the standard lens arrangement, which are macroscopic components, but at the CCD array location, we have a microscopic lenslet array as well as the CCD backplane structure itself. What we would do in a simulation like this is define the optical components within ASAP, propagate the light through the optical system on a macroscopic basis until the wavefront was an infinitesimal distance in front of the location of the lenslet arrays. At this point in time, we would do a calculation of the energy or field distribution within ASAP and then export that data, which could then be used with the FDTD Solutions program. Let's run the file and take a look at what's happening. In this particular case, what we're going to simulate is light coming from an on-axis field point as well as an edge of the field point. We'll look at the wavefront directly along those two locations, on-axis and the edge of the field point, and then we will also look at slightly tilted wavefronts relative to those two paths. What this will allow us to do is when we propagate the energy on the microscopic scale through the lenslet arrays, we'll be able to calculate the crosstalk between the lenslets and the pixels. And here we see the definition of the system. Now what we see is the field energy distributions. This is for an on-axis field point centered along that axis. And this is for a point slightly off the optical axis, tilted relative to the prior location. And another tilted field point as well. Similarly, we can look at data along the edge of the field point. And then we will calculate information at two locations tilted slightly to that reference. After we have captured all of this field information in ASAP, we can now export the data from ASAP in a format that will be read by the FDTD Solutions package, where we can then do the microscopic calculations, getting information about crosstalk, energy information, etc. Conversely, you can also start with the microscopic scale with the FDTD Solutions program and then export data from that program and import it into ASAP. You can do this multiple times through any particular optical system, so you can easily start within ASAP, do calculations within the FDTD Solutions program, and then return data back into ASAP for the final calculations.